Hello everyone, welcome once again to Maths by Gurpreet Sekho. We are going to continue with our chapter Introduction to Trigonometry, that is of 10th class. And so far we have done our first example, and today we are going to discuss the remaining examples, that is example second, third, fourth and fifth of the very first exercise. So let's clear some of more concepts. Let's start with that. This is our very first example of today's video. That's actually example second. It's given that if angle B and angle Q are acute angles, angle B and angle Q are acute angles such that sine B is equals to sine Q. Now what is given? That sine B is equals to sine Q. Now just keep in mind the previous studied facts that sine is equals to what and cos is equals to what, tan is equals to what, like from the code that I have just discussed in the previous video. Alright. Now sine B is equal to sine Q. We have to prove that angle B is equals to angle Q. Now these two angles are from two different triangles, as you can see in the figure. So we will be applying the concept, that is, we have to prove that these triangles are similar to each other. Then we will just equate the corresponding angles, that angle B is equals to angle Q. Apart from it, there is no other way to prove that angle B is equals to angle Q. We have to prove that these two triangles are similar. Now the similarity of triangles is discussed in the triangles chapter of 10th class, so you just can have a look at your book and to know that how we can prove two triangles to be similar. I'll be releasing videos of triangles chapter of 10th class soon, so don't worry about that as well. But for time being, we'll be limiting our knowledge to only the concept of similarity that is going to be used in this example exclusively. So sine B is equals to sine Q. Now we have studied that sine is equals to perpendicular over hypotenuse, right? Now for this clearance you have to watch the previous video, that how sine is equals to perpendicular over hypotenuse. Now sine B from this triangle is equals to AC upon AB, correct? And from the next triangle, that is sine Q, it is equal to PR over PQ, right? We have just found the values from the figure, right? Now sine B and sine Q are given to be equal in the statement, so we will just equate the right hand sides as well. That is AC over AB is equals to PR over PQ. Now here is the thing, that if the ratio of corresponding sides of two triangles are equal, then those two triangles are similar to each other. Now the two sides, the corresponding ratio of two sides is coming out to be equal. Simply we have to prove that the ratio of third corresponding side is also equal to these two. So we are done with AC and PR, it's equal to each other, and AB and PQ. The side which is left is only BC and QR. So we have to find the value of BC and QR, and we have to equate the value of BC over QR to these two ratios. Only then these triangles will be similar triangles, and we can easily write that angle B is equals to angle Q. So in order to prove that BC upon QR is equals to these two ratios, we need to know the value of these two ratios as well. So just let it equal to K, okay? Just suppose that it is equal to K. So now our motive is that BC upon QR must be equal to K. Only then these three ratios will be equal to each other. Now firstly, let's find the value of BC. Apply Pythagoras theorem on the triangle ABC. What will you get? AB square is equals to AC square plus BC square, or you can say that BC is equals to root AB square minus AC square, okay? In the second triangle as well, apply the Pythagoras theorem, that is PQ square is equals to PR square plus RQ square, or you can say that RQ is equals to root PQ square minus PR square. Alright, so we have the values of BC and QR. What we have to find BC upon QR. So just fill in the values. What is BC? That is AB square minus AC square. What is QR? That is PQ square minus PR square. Correct? Now what is the value of AB? You can see that AB is equals to K multiply PQ. How? Because when you will rearrange this thing, as you know that we have to prove that BC upon QR is equals to K. It means if you have to prove it equal to K, then K must be taken out as a common factor from the numerator. So if we fill in the value of AB as AC upon K, it will only complicate the things. That is why just rearrange itself, and AC, the AB will be shifted to PQ, the numerator of PQ, and PR will be shifted to the denominator of AC. So what will it look like? Let me just write. You will get AC upon PR is equal to AB upon PQ is equal to K. Alright, so now just have a look at this equation. What is AB? That is K multiply PQ, and AB square will be equal to K square PQ square minus, what's the value of AC? KPR. And what's the value of AC square? K square PR square. And don't touch the denominator, write as it is, because it will only simplify things in a speedy way. Now take K square as common factor, and when you will take K square out of the root, what will you get? Only K, and under the root there will be PQ square minus PR square upon PQ square minus PR square. So these will cancel each other and you will get equal to K. That's why BC upon QR is also equal to K, which is further equal to PR upon PQ, AC upon AB. Therefore AC upon AB is equals to PR upon PQ is equals to BC upon QR, which means, what does it mean? Therefore triangle ABC is similar, this is the sign of similarity, is similar to triangle PQR. So now there is a theorem that exists which say that if the two triangles are similar, then their corresponding angles are equal to each other. So now we have to deal with only one corresponding angle, that is angle B and angle Q. So therefore as a result, angle B will be equal to angle Q. Just state the theorem which I have just spoken and you have got your answer. This is how to deal with the angles that are given in two different triangles, because if those are given in one same triangle, we can only use the concept of trigonometry easily and we can prove that thing. But if those are given in two different triangles, then you have to involve the concept of triangles a bit as well. Okay, so let's move ahead. This is our third example, and in this example it's given a diagram and they have written as well, but I have made a diagram directly. Angle B is given to be theta and AB is equals to 29 and BC is equals to 21 units. We have to find the value of these two expressions, that is cos square theta plus sin square theta, cos square theta minus sin square theta. Now there is a pre-existing identity that cos square theta plus sin square theta is always equal to 1, provided that both angles are equal. But we have to prove this thing in this sum. So firstly, what we have to do, we have to fill in the value of sin theta and cos theta, as simple as that. So what is sin theta equal to? That is perpendicular over hypotenuse. Now what is perpendicular? That is AC. What is hypotenuse? That is AB. Now you can see that we don't have AC but we have AB. So let's move to cos theta. Cos theta is equals to base upon hypotenuse. It means BC upon AB. What will you get? 20 BC, that is 21. So 21 upon 29, right? So you have found the value of cos theta, but we don't have value of AC, so that's why we cannot find the value of sin theta. So we will simply apply Pythagoras theorem, because it's pretty much understood that it's a right angle triangle, as trigonometric functions only holds in right angle triangles. So therefore AB square will be equal to AC square plus BC square, right? What's AB square? That is 29 square. Now BC we already have, so minus of 21 square, and there will be root which will be equal to AC only. Yeah, I have skipped one or two steps, but you can see it's pretty much easier. So root A square minus B square, you can apply it. 29 minus 21, 29 plus 21, the identity of A square minus B square, right? So what will it be equal to? 29 minus 21, that is 8, and 29 plus 21, that is 40. 29 plus 21, yeah, that's 50, I guess. Yes, sorry for that. Now 8 fives are 40. What will you get? 400. You know that root 400 is equals to 20, so therefore we have got AC is equals to 40. Now you can fill in the value of sine theta as well. So sine theta is equals to, that's 20. Sine theta is equals to 20 upon 21, and cos theta is equals to 21 upon 29. Yeah, so now 70% sum is already solved. Just fill in the values in the expression. Now cos square theta plus sine square theta will be equal to 20 upon 21 square plus 21 upon 29 square, that is AC upon AB. AB was 29. Yeah, so it's miswritten again. Alright, now denominator is same, you can add it simply. It means 20 square plus 21 square upon 29 square. Okay, so 20 square, that is 400. 21 square, that is 441. 29 square, that is 841. 441 plus 400, that is 841. 841 upon 841 is equals to 1. So we have found the value of cos square theta plus sine square theta, that is equal to 1 only. We also have to find the value of cos square theta minus sine square theta. So what we will do, 21 square upon 29 square minus 20 square upon 29 square. You can clearly write 21 square minus 20 square upon 29 square. What's it? A square minus B square, that is A minus B, A plus B. 21 minus 20, that is 1. 21 plus 20, that is 41 upon 841, because 29 square is 841, so your answer is 41 upon 841. So this was our motive, to just find the values of the given expressions, that is cos square theta plus sine square theta and cos square theta minus sine square theta. The only thing that you have to keep in your mind is the basics, that what is sine theta equal to? Is it perpendicular over base or perpendicular over hypotenuse or whatever it is? You have to keep the basics in your mind before proceeding. So let's move to the next example. It's our fourth example. It's given that tan A is equals to 1. So this is our angle under consideration. Tan A is equals to 1. We have to verify that 2 sine A cos A is equals to 1 or not. Now sine A and cos A, we have to find the values of sine A and cos A. So firstly write what is sine A and cos A equal to. Now sine A is equals to perpendicular over hypotenuse. So now most of the students will take AB as perpendicular, but I have told you in the previous video as well that the side which is opposite to the angle into consideration will be our perpendicular. So here angle under consideration is A and the side opposite to A is BC. So BC will be our perpendicular and hypotenuse will be AC only. And what is cos A equal to? That is base upon hypotenuse. So now we know that hypotenuse is AC any which ways, and if this is perpendicular, this will be base. So cos A is equals to AB upon AC. So basically what we have to do, we have to find the values of BC, AC, AB and AC. In fact, all the three sides. Only one thing is given, that tan A is equals to 1. So let's fill in the value of tan A as well. Now what is tan A equal to? That is, yes, 1, that is given, but in the form of the sides of triangle, it is equal to perpendicular over base. So what is our perpendicular? That is BC, and what is our base? That is AB. So now you can deduce one result, that BC is equals to AB, because when AB will be multiplied to 1, so BC will be equal to AB. Now this thing is here. If BC is equals to AB, just suppose that these both are equal to K. So now we have BC equal to K, we have AB equal to K. So now can we find the value of the remaining side that we have BC, AB? We can easily find the value of AC. Okay, so in the right angle triangle, just apply the Pythagoras theorem again. AC square is equals to AB square plus BC square. Now here is the thing, don't consider the bases and perpendiculars that we have considered here, because the Pythagoras theorem is applied with respect to the right angle. So with respect to right angle, this is our perpendicular, this is our hypotenuse, this is our base only. So yeah, just keep these little things into mind. So AC is equals to root AB square plus BC square. Now what's AB? That is K square. What's BC? That is K square as well. Root, that is 2K square. What will you get? K root 2 as the value of AC. Okay, because K square, when it will be taken out of root, you will get K only and root 2, K root 2. So AC is equals to K root 2. You have BC is equals to K, you have AB as well. So just find the value of sine A. What is sine A equal to? That is BC upon AC. What is BC equal to? That is K. What is AC equal to? K root 2. You will get 1 upon root 2, right? What is cos A equal to? That is AB upon AC. What is AB equal to? K. What is AC equal to? K root 2. So we will get 1 root 2. Just fill in the values in the given equation that we have to verify. Now 2 sine A cos A is equals to 2. What's the value of sine A? 1 upon root 2. What's the value of cos A? 1 upon root 2. Now root 2 multiply root 2, that is 2, and 2, when they will be divided, you will get 1 as an answer. So yeah, we have verified that the given equation, the given expression is a correct one. All right, it was an easy one. So just you have to use the given things very wisely. So let's move to the next example. In the last example of the first exercise, it's given that in a right angle triangle, which is right angled at P, OP is equals to 7 centimeter, and this is one equation that OQ minus PQ is equals to 1 centimeter. We have to find the value of sine Q and cos Q. So we know that to find the value of sine Q and cos Q, two sides are required, but here only one side is given. So it's automatically understood that we have to firstly find the remaining sides, and then only we'll be able to find the value of sine Q and cos Q. It's a right angle triangle, so there is no other option than applying Pythagoras theorem to this triangle in order to find the remaining sides. So just simply apply the Pythagoras theorem and then see what happens. OQ square is equals to OP square plus PQ square, right? Okay, so OQ square is equals to PQ square plus OP square. Now you have the value of OP square, so just substitute it. That is 7 square plus PQ square. Now here is one thing, that in an equation, if one thing is unknown and all the things are known, then we can find the value of that thing, that unknown thing. But if more than one things are unknown, then we have to just convert the remaining unknown things into only one type. Okay, because it's OQ and it's PQ. Now either we can just convert the equation into PQ, or we can convert the equation in terms of OQ. It's totally up to us. It's given that OQ minus PQ is equals to 1. We can clearly see that OQ is equals to 1 plus PQ. Just fill in the value. 1 plus PQ whole square is equals to 7 square plus PQ square. Now the whole equation is in terms of PQ. So we can easily find the value of PQ. Now just expand the square. 1 plus PQ square plus 2PQ is equals to 7 square plus PQ square. Now these two sides are same, so of course they are going to be cancelled. 1 plus 2PQ is equals to 7 square, or you can say that 2PQ is equals to 49 minus 1, or PQ is equals to 48 upon 2 is equals to 24 centimeter. PQ is 24 centimeter. You can see that OQ is 1 plus PQ. So 1 plus PQ, that means 24 plus 1, that is 25. So OQ is simply is equals to 25 centimeter. You have PQ, you have OQ, you already had OP. You can easily find the value of sine Q. Now what is sine Q? That is perpendicular. What is our perpendicular now? Because it's opposite to the angle. So it's OP divided by hypotenuse. Hypotenuse is OQ. So what is OP? That is 7. What is OQ? That is 25 centimeter. And similarly, we can find cos Q. Cos Q is equals to base. What is that? Is PQ upon, of course, hypotenuse OQ. What is PQ equal to? That is 24 upon 25 centimeter. This is how you can find the trigonometric ratios in a given triangle using Pythagoras theorem step by step, and applying these kind of steps. Okay, so yeah, this was it for today, and now our first exercise is completed. If you have any problem in any example, any sum, any concept, you can DM me. You can use comment section as well. The link of my Instagram ID is given in the description, so feel free to contact me. Apart from that, don't forget to press the subscribe button before leaving my channel, guys, because it really motivates me to deliver these kind of videos on a regular basis. All right, thanks for watching. All the very best, and see you in the next video.